Okay, so let's remember this 173 coulombs. We're going to need to use it again in part D. But real quick, part C here is a conceptual question again. And to understand this one, so it asks us why our oxygen volume was different than the hydrogen volume, which is shown in the picture up there. We get more hydrogen than we do water. And the reason for that is, again, if we look at our overall balanced equation where we have water converting to hydrogen and oxygen gas, this is not balanced. When I did this first time, this is not balanced. So we have two oxygens, two there to balance the hydrogens, we have two there. So every time we're splitting up one of these water atoms, molecules, we get two hydrogens and only one oxygen. So the stoichiometry, as indicated by this balanced equation, tells us that we're going to get more hydrogen than we are oxygen. It's going to be in a ratio of 2 to 1. Okay, so that's for part C. Part D now, we're going to have to use our current, or our charge from part B. So if we know how many coulombs, in this case we'll start with that, 173 coulombs. Okay, and it's asking us how many moles of hydrogen were produced. Okay, and so what we need to utilize in this case is going to be Faraday's constant. And Faraday's constant, which again this is on your equation sheet, is going to be 96,500 coulombs per mole. And the mole in this case will correspond to the electrons that we're sending through. So the charge is from the electrons, so we have 96,500 coulombs for every mole of electricity. Okay? And so we had that, and we have, and so the mole, this will tell us how many moles of electricity. So coulombs are going to cancel out. Moles of electrons, excuse me. Moles of electrons, then the stoichiometry for that is going to be found in our overall equation. And so part of it, where we're forming the hydrogen, is going to be at the cathode. Okay, so we're going to take two waters, two electrons. We're going to give us hydrogen and hydroxide. Okay, and so in our overall equation, since we're donating some electrons, gaining some electrons, and they're just transferred, we don't have the electrons. But we need to take a look at the half reactions to see where it's important. And so stoichiometry is going to take place here. So in terms of hydrogen, for how many electrons we run through it, well, for every 2 moles of electrons, we're going to get 1 mole of hydrogen. Sorry about the pen used there. And so when we do that, calculate everything, our number of moles is going to come out to 8.96 times 10 to the -4th moles. So then after that, the next part, in part E, what they do is they ask us, based on that amount, they want to know, what the volume would be. So we're talking about a gas, so it's going to have volume here, and all this is going to be going to be ideal gas law using this number of moles, where PV is equal to nRT. Volume is going to be nRT over P. And when we do that with the values that we have, we end up getting a volume of 0.0219 liters. I'm going to trust you guys know how to do this part, and we'll leave it at that. Okay, one last part to this. It asks us why we had more volume in the container there than we needed to, and we just got to remember this is collected over water. And anytime we have something over water, we're going to have the vapor pressure of water to take into account. So that's going to add a few moles and some extra volume into that compared to what we calculated.